to today's lesson in physical sciences. My name is Tandiwe. This lesson is brought to you by Gauteng Department of Education in collaboration with Saipono. Today's lesson, we are going to look at assistant basis. However, we are just going to concentrate on the calculations on assistant basis. Therefore, before we start this lesson, I would like you to have your periodic table ready, your calculator ready, because we'll be engaged in a lot of calculations today. And I will also give you time so that you can interact with every calculation and make sure that you perform those calculations before I give you possible answers. Now, as we know that we are going to look at calculations based on titration, you need to remember that as we are going to look at titration, you need to remember what is acid-base titration, which is the experiment that some of you have already performed with your teachers because you wanted some concentration of either an acid or a base or volume of an acid or a base. So this is the method that we use to calculate concentration, volume of an acid or a base. Now, we know that when we are performing titration, we need to know the acid and the base that are reacting. We have to choose a suitable indicator. Now, how do we choose a suitable indicator? A suitable indicator will only be chosen if we know the strength of an acid and a base. Therefore, that is why when we started with our acids and bases, we looked at different strengths of acids and bases so that at the end of the day, we will know which indicator is suitable to be used in that acid-base titration or reaction. We know that the indicators that we have, they are methyl orange, phenolphthalein, and bromothymol blue. And when we were explaining the three indicators that are examinable, we said methyl orange, you'll use it when you know that at the end of the day, you're going to have an acidic solution. Phenolphthalein, you know that you're going to use it when you have a basic solution, and bromothymol blue when you have a neutral solution. How does a solution becomes acidic or basic or neutral? Definitely in that case, it will depend on the strength of acids and bases that are reacting at that particular time. Therefore, you need to also define the equivalence point, which is the point at which the acid or base has completely reacted with each other. Do you know that always when you deal with physical sciences, you might be expected to define terms. Therefore, equivalent point is one of the terms that you need to define coming to the titration processes, which is the point whereby the acid and base has completely reacted with each other. You also need to define the end point. This is the point where the color of the indicator changes. Definitely, we know that when the color of the indicator changes, it also showing us that it means the acid and the base has reacted with each other. Therefore, these are the two definitions that we need to understand as we'll be doing our acid-base titration. Therefore, as I said at the beginning, we are going to perform calculations, stoichiometric calculations based on acids and bases, whereby we are going to look at strong acids with strong base, strong acid with weak base, or weak acid with strong base. Our calculations may include percentage purity. Therefore, it is very important that you just remind yourself on how were we calculating percentage purity from our grade 11, which is our previous grade, which is very important because if an examiner expects you to calculate percentage purity, you need to be in a position to do that. We also need to know the titration that we normally use as our example is the titration between the oxalic acid and sodium hydroxide. The first thing that you need to understand is that if we are expected to use oxalic acid and sodium hydroxide, we need to identify the oxalic acid, and we know that oxalic acid is going to be our weak acid. Therefore, we know that our sodium hydroxide is going to be our strong base. Then immediately, you need to think about the type of an indicator that you are going to use when oxalic acid reacts with sodium hydroxide, which you know that is going to be your phenolphthalein. Therefore, as you are going to perform those experiments, definitely a suitable indicator is very important for you to choose because the color must change based on the strength of the indicator of an acid and the base that are reacting. You also need to list the apparatus needed or identify apparatus for the diagram, and also interpret the given result to determine the unknown concentration. So as I said, that during our titration processes, we will definitely need to know the unknown concentration and also sometimes calculate the unknown concentration. Now, let's look at what we also did. We also talked about the pH scale and the pH. We know that different acids and bases have different pH based also on the strength. And we know that the pH scale ranges from 0 up to 14, whereby we know that the middle one represents neutral, less than 7 represent acidic, and greater than 7 represent basic. And we also know that the numbers that we are going to find when we calculate pH or when we look at the pH scale, they will also indicate the strength of an acid and a base that are reacting. We know that from 0 up to maybe 3, if I can just choose 3, we know that we'll definitely have strong acids. And then this side, we're going to have weak acids. This one we know is neutral, just close to 7, plus or minus 7. And then we start and have the weak bases. And then we add to end with the strong bases, which have a very high pH scale. Therefore, after understanding that, we also calculated the pH using the formula pH is equal to minus log the concentration of H2O plus. And we also talked about the Kw, which was the constant ionization of water, whereby when we are looking for the pH of a base, we know that the base doesn't have the H2O minus because it was according to Arrhenius, who said a base can produce a hydroxide ion. Therefore, if the pH value requires us to have H2O plus, we need to use the Kw value, whereby Kw is equal to 1 times 10 to the exponent minus 14, for us to be able to find the hydronium ions in a base, because at that point in time, we'll be having what? Hydronium ions. So this is the information that we used previously, which is going to be also part of this lesson, because we are going to look into the acid-base calculations in totality as we are going to continue the lesson. We know that acids and bases also, we can look at their strength looking at the interpretation of the Ka and the Kp value, whereby Ka represent the ionization constant of an acid and Kb represent the ionization constant of a base. We already know that if we have a Ka value which is greater than 1 or 1 greater, it means we have a strong acid. And if the Kb value is greater than 1, it means we have a strong base. Therefore, there will be an instant whereby an examiner can give you a Ka or Kb value so that you can identify the strength of an acid and a base that is reacting. Therefore, these values are very important for us to know, because they will definitely give you the strength of acids and bases. And we know that we can compare acids, strong acids and weak acids using the pH, which I already explained in terms of the scale that I just gave you on our previous slide. And also we need to talk about conductivity, which is what we emphasized previously, to say conductivity, whenever we have a high conductivity, it means we have a strong acid conductivity. It means the acid is strong. And also when we have a high reaction rate, it indicates that also that acid or that base that is reacting is strong. However, the examiner just need us to know the reactivity and the conductivity in terms of strong acids and weak acids. So we'll only compare strong acids and weak acids in terms of conductivity and also in terms of the reaction rate. Now, as we are going to deal with calculations, it is very important, as I started to say, make sure that you have your periodic table ready, so that whenever we want to refer to the periodic table, you have it with you, so that we can also be able to find the atomic numbers if they are required, or the atomic masses if they are required. Because definitely, as we are going to do these calculations, we will be required maybe sometimes to calculate the molar mass, which definitely will need you to be referred to from the periodic table. Therefore, we know that our periodic table will be giving us our atomic masses and our atomic number and our electronegativity. Therefore, the periodic table is very handy when we are doing these calculations. And what you must understand is that always when you are required to calculate the molar mass or the molecular mass of a substance, you will definitely be awarded a mark for that calculation, because that calculation qualifies for a mark because you've used a scale to refer to the periodic table, which is the table that we definitely use in all the chemistry that we do from grade 10 up to grade 12. Now, let's look at the revision that from grade 10. We know that in grade 10, we calculated the number of moles. The number of moles will assist us also in this topic, a topic of acid and basis calculation, because we will always be referred to calculate the number of moles, because most of the time we work with number of moles. Therefore, the formula that we use in grade 10, starting from grade 10, is also that one of N, which represents mole, is equal to the mass over the molar mass. So the molar mass, we know that we are going to use our periodic table in order to get the atomic masses that will definitely assist us to get the molar masses. Now, let's look at these examples and remind ourselves on how did we use this formula for us in order to calculate the number of moles. We are starting here as a basic because we are building from the known to the unknown. I understand that some of these questions on the calculations, they might be a little bit challenging if you don't know the basics. So that is why it is very important that you start from the basics. Now, when we are looking at the number of moles that we are provided, here the first question says, calculate the number of moles, and we are given 96 grams of sulfur. Therefore, it means now, if we want to calculate the number of moles here, we know that we are going to use the formula N is equal to M over molar mass. And what you need to understand is that the other M, which is the molar mass, is capital letter M. Definitely, you need to represent the correct molecular formula and correct symbol for each formula. Therefore, we are looking for the number of moles. We are given 96 divided by. Now, we need to find the atomic mass of sulfur. So what we are going to do, we are going to go back to our periodic table. If you look at the periodic table, you can see that the atomic mass of sulfur is 32. Therefore, you will just go straight to the periodic table and put 32, and then you calculate the number of moles. If you say 96 divided by 32, you will definitely get 3 moles. If you can use your calculator, as I said, that make sure that your calculator is closer to you also, so that you calculate and find the number of moles. So we are going to get 3 moles for our first, which is a very simple calculation that you can think about. But remember, this is what you did from grade 10, which is going to be what we're going to use as we are going to do these complex calculations that we are going to look at today. Then the next one says calculate the mass. You see the second one now, it doesn't want you to calculate the number of moles. You are provided with the number of moles. They want you to calculate the mass. So how are we going to calculate the mass? We can still use the same formula. N is equal to mass over number of the molar mass. Now, we are given sulfuric acid. So for us to calculate the molecular mass of sulfuric acid, we definitely have to refer to the periodic table. What is the molar mass of sulfuric acid? So we are going to find the M of H2SO4, which is what we are going to use. When you look at the periodic table, you can refer. Each hydrogen is having 1 as their atomic mass, which is 1 times 2, plus sulfur, we have already found it as 32, and plus oxygen is 16 times 4, because it's O4, H2SO4. Therefore, for us to calculate the molar mass, we are going to add all the atomic masses together, and also representing how many atoms are there for each atom that is represented by the molecular formula. Therefore, we are going to get what? 98 grams per mole. Therefore, after getting the 98 grams per mole, which is the molar mass of sulfuric acid, that's when now you can say the number of moles we are already provided is 0.5, which is equal to mass divided by 98. So when we say 98 multiplied by, we can say 0.5 because we know that it's 0.5, and then we are going to get the mass. As you cross multiply, you're going to get the mass of this substance as 49 grams. It is always very important to indicate the units for every answer that you're going to give at the end. Even though we don't put units as we are doing the calculation, but definitely as we provide the answer, the units must also accompany the answer, because the units are part of the answer. Therefore, when you look at the last one, they are giving you the moles and they are giving you the mass. They want you to calculate the molar mass. So we'll definitely use the same formula just to manipulate and find our molar mass, which is what we are not going to do now. You can do it on your own and see whether you can find the molecular mass of this formula. Now let's go to the next formula that we also used in grade 11 to calculate the number of moles. We use the formula N is equal to V, whereby V represents the volume, and this one represents the molar volume. Now you need to understand that as part of our data sheet, the molar volume is provided to us, and the value of the molar volume is 22,4 decimeter cube. Therefore, this molar volume can only be determined when you are told that this experiment or this system is at STP. STP, which represents standard, temperature, and pressure. Therefore, it means if the examiner didn't indicate that the system is at STP, we cannot use this formula because this molar volume is only 22,4 at STP. Therefore, you need to firstly find out whether are you at STP or not for you to use this formula. Now, let's look at this calculation where we involve this formula, which is N is equal to V over Vm. The first one says calculate the volume occupied by 0,5 mole of sulfur dioxide. There are two things that are involved here. You need to be able to calculate. However, before you calculate this volume, you need to firstly know the formula of sulfur dioxide, because in this case, sulfur dioxide is provided to you as the name, so you need to know the molecular formula. And we know that the molecular formula of sulfur dioxide is SO2. Therefore, what are we looking for? We are looking for the volume. We know that, okay, the volume that we are going to calculate is going to be N is equal to V over Vm. We are provided the number of moles 0,5. We are looking for the volume. We know that this is going to be 22,4. So when you cross multiply to calculate the volume, and you need to remember the units of volume, which is going to be 0,5 multiplied by 22,4. And the answer that you are going to get 11,2 decimeter cubed, which is the volume that will be occupied by that gas of 0,5 moles at STP. We can also look at the second example, whereby they say calculate the molar at the volume occupied by 20 grams of oxygen. Now, in this case, the examiner has given you the mass and the molecular formula of a substance. You are not provided the number of moles like the first one. Therefore, it means for you to use this formula, you firstly need to find the number of moles of this oxygen. Therefore, you need to start by saying, we are going to start by saying N is equal to M over M, whereby we are looking for the number of moles. The mass we are provided is 20. We know that oxygen is 16 as an atomic mass. However, there are two oxygens that are involved. So it's going to be 16 times 2, which is going to be 32. Therefore, we're going to say 20, which is the mass of oxygen, divided by 32, which is the molar mass of oxygen, to give us 0,625 mole. Then after getting now the number of moles of oxygen, we can now then go back to our formula that say N is equal to V over Vm, and substitute our number of moles, which is 0,625 V over 22,4. Then 0,625 multiplied by 22,4, which is going to give us 14. So our volume now here is going to be 14 decimeter cubed. As I was always saying, please make sure that you include the units for every response that you give at the end, because this answer, if I'm marking this, I'm going to give one for the calculation of the number of moles, one for using this formula, and maybe one for the formula or I can also give 1 for the substitution. So the 4 marks that I can give for this question will definitely be 4 if your answer is having the units, which makes it to know which variable were you calculating as we're busy. The last one says calculate the mass of carbon monoxide when that occupies 40 cubic decimeter of at STP. Now the volume is provided to you as part of the data. And you know that 22,4 is our STP. Now they want you to calculate the mass. How are we going to get the mass? We can only get the mass if we know the number of moles. Therefore, it means for us to be able to do this calculation, we need to firstly find the number of moles, whereby we are going to say N is equals to V over Vm. Therefore, the volume is 40 over 22,4. Then we find the molar mass, the number of moles, which is going to be 40 divided by 22,4, and it gives us 1,78, therefore, which is the number of moles. Therefore, for us to calculate the mass, therefore, we're going to say N is equals to M over M. Carbon monoxide, the formula or the molecular formula to calculate carbon monoxide is CO. Therefore, how are we going to calculate the molar mass? We know that for the molar mass of CO, we are going to say 12, which is going to be our carbon dioxide, not carbon dioxide, carbon 12 plus 16, and it gives us 28. Therefore, we are going to say 1,78 is equals to M over 28, and then we calculate and we get X number of grams, which is our mass. So this one was just starting by taking us to calculate the number of moles before we can go back and calculate the mass. Then the next formula that we are going to look at is the one now that we calculated concentration. As I said that as we are going to do these calculations, we will also be determined to calculate the unknown concentration. So this formula from grade 11 assisted us to know how to calculate concentration, whereby N represents the number of moles and V represents what? The volume of a substance. And this is what is our concentration. Now, when we are looking at the concentration, we can look at the first example that we are not going to do all the examples, definitely, because we won't have enough time. But when you look at the first example, it says, calculate the concentration of 10 cubic decimeter of a solution that contains 0,6 moles. So we are already provided with the number of moles. So we know that we're just going to say C is equals to N over V. And then we look at what is it, what we are given the 10 cubic decimeter as our volume and 0,6 as the number of moles. So it's going to be 0,6 divided by 10. And then we are going to find our concentration, which is going to be 0,6 divided by 10. And we get our concentration as 0,06 moles per decimeter cube. In our previous lesson, I explained that immediately when the concentration is like this, which is less than 1, most of the time it indicates that that particular solution is more diluted because there is more of a volume of a solvent than the solute. So immediately when the solvent is more than a solute, you will definitely find a diluted solution because that is exactly what is happening. You will have more. That means the solution or that solvent is mostly dissolved. So it means it is more diluted. So you can find this as this number of concentration. But remember, the units to calculate concentration is moles per decimeter cube because you are dividing moles and decimeter cube. When you look at the second one now, you can see that they say calculate concentration again, but now you are provided your volume in cubic centimeters. Remember, the SI units that you use to calculate the volume is cubic decimeters. Therefore, whenever you are given or you are provided cubic centimeters, you definitely have to convert them back to cubic decimeters. How do you convert cubic decimeter? How do you convert cubic centimeters to cubic decimeters? You just say those cubic centimeters that you are provided divide by 1,000. So whenever you are provided cubic centimeter, you just divide by 1,000, then they will move straight to cubic decimeters. Therefore, If you are given 250 cubic centimeters, you divide by 1,000, then you are going to get your cubic decimeters. And in this case, it's going to be 0.25 cubic decimeters. Then you are also provided with the number of moles. So the only thing that was different here is that our volume was in cubic centimeters and we are still provided with the number of moles. So for us to calculate the concentration, it means we are still going to say C is equal to N over V. We know that our number of moles as they are provided here, let's go back, they are 2,4 moles. Therefore, it means we are going just to say 2,4 divided by 0,25. Then we are going to find our concentration. So it's going to be 2,4 divided by 0,25, which will give us 9,6 moles per decimeter cube. And from the concentration that you are provided, you can see that this solution now is a little bit concentrated, or is more concentrated, because as you look at your concentration, it is more than 1, which indicates that now the solvent or the solute is more than the solvent. So those are the things that you need to check. As I'm doing these calculations, what I will urge you to do, make sure that you use your calculator. Make sure that as we are calculating, you use the calculator that you are familiar with. Always use the same calculator so that you are also familiar with the operations of that calculator. Even when you go to the examination, make sure that you use the same calculator so that you are not confused with the operations of the calculators, because the calculators are not the same. When you look at this one, you can see also that we are given 150 cubic centimeters of now 73 grams of sulfuric acid. This one, we know that the first thing that we need to do, we need to convert those cubic centimeters into cubic decimeters, whereby we are going to just say 150 divided by 1,000, which will make us to get the cubic decimeters, which are 0.15 cubic decimeters. And also, you are given the mass and the molecular formula. Immediately when the examiner gives you the mass and the molecular formula, the examiner actually is providing you the number of moles. Therefore, you just go straight to the formula. N is equal to M over the molar mass. Therefore, you know that we are looking for the number of moles. We have 73 grams of sulfuric acid. We previously calculated the molar mass of sulfuric acid, which was 98. Therefore, we can find our number of moles, whereby we're going to say 73 divided by 98, which will give us 0.74 moles. Therefore, after finding the number of moles, we can then go to C is equal to N over V. And we know that now our number of moles is 0.74. Our volume, we calculated it, or we converted it, because it was provided to 0.5. So therefore, we are going to divide this answer with 0.15, which is going to be 4.96 moles per decimeter cube. So these are the calculations that I felt we need to start with, so that when you go further, you know where we started with our stoichiometric calculations and how did we calculate the number of moles in different instances, when we have a concentration, when we have the moles, or when the mass and the molar mass, and also where we have the molar volume. Now, let's look at these questions now. What we are going to do, as we are doing each and every question, I will just give you some few minutes or few seconds to try the calculation before we go to responses. The main aim of doing this is for me to see whether you are able to interact with these questions. We are still having our WhatsApp number that we are using to interact with you. I will definitely try to respond to some of the questions that we have on our WhatsApp if the time allows, but don't hesitate to WhatsApp us on 063 629 3655. This number will assist you to interact with us and also to ask questions where you have challenges. Now, let's look at the typical exam questions. The way the examiner will expect you to answer questions based on question number 7, normally 7.2 or 7.3, depending on the type of question, because we know that our acids and bases are question number 7. Therefore, when you are expecting to have acids and bases, as part of your chemistry paper, you just go to question number 7. That's where we'll definitely get the paper because the structure of the paper hasn't changed. Now let's look at 7.2, which was I just snapshotted this question from one of our previous question papers. It says the pH of hydrochloric acid solution, and they gave us the formula of hydrochloric acid, which is HCl, is 1,02 at 25 degrees Celsius. Remember, the pH doesn't have units. Therefore, that is why you can see that even though the examiner is provided, even when the examiner is providing us with the pH, there are no units that are involved when coming to the pH. Therefore, you are provided with the pH of this hydrochloric acid. Now, the question says, calculate the concentration of hydrochloric acid, and this qualifies for 3 marks. Now, what I'm going to do, because this is 3 marks, I'm just going to give you at least 1 minute for you to try and calculate the pH of hydrochloric acid. And then after 1 minute, we're going to continue with other calculations. So our 1 minute start now. Okay, welcome back, grade 12s. Let's see now how did we calculate our pH. I will just go straight to say, when you look at hydrochloric acid, why is the examiner giving us this pH? You can see that the pH is less than a 7 and is closer to 0, which is 1. So this is another indication to say that hydrochloric acid is our strong acid. It's our strong acid. And what do we know about strong acids? We know that strong acids, they do what? They ionize completely when they react with water. So as hydrochloric acid ionizes completely as it reacts with water, we are supposed to calculate the concentration of hydrochloric acid. However, we know that our formula for pH is pH is equals to minus log the concentration of H3O plus ions. Therefore, the concentration of hydrochloric acid is not provided by the formula of pH, but what we are provided is the concentration of hydronium ions. Therefore, what is the relationship between hydrochloric acid and hydronium ion as hydrochloric acid ionizes in water? We also know that as hydrochloric acid ionizes in water, it's going to give us what? H plus or H2O plus, let me just say plus water, H2O plus Cl minus. And because it ionizes completely, we already know that the concentration of hydrochloric acid is going to be the same as the concentration of the hydronium ions and the concentration of the chloride ions. Therefore, it means if we can be able to find the concentration of hydronium ions, we already know the concentration of hydrochloric acid. And that is based on the information that we knew from the previous lessons that hydrochloric acid is a strong acid and it ionizes completely. Therefore, if you look at the concentration at the calculation now, you'll find that we are going to use our formula pH is equal to minus log the concentration of H2O plus. Therefore, we are going to substitute our pH, and for substituting the pH, we are going to provide a mark because it means we understand what is the pH and we can substitute it in our correct formula. What I can advise you on is that make sure that when you copy the formula from the data sheet, you copy the formula correctly. I cannot advise you to manipulate or to start manipulating the formula. But we know also that we can also use the formula that says the concentration of H2O plus, which was the formula that I was always preaching as I was giving you this, is equals to 10 log to the exponent minus pH, which is going to be, when you substitute the pH here, is going to be minus 1,02, and you're going to still get the same answer of 0,0955 mole per decimeter cube, which is our pH of AC, which is our concentration of ACl. Therefore, our concentration of ACl is 0,0955 moles per decimeter cube. And the reason we know is because ACl ionizes completely. So its concentration is the same as the concentration of the ions that is going to be formed after ionizing. So now we have the concentration of hydrochloric acid. Now let's look at the second question. When you look at the second question now, it says this HCl. What do you mean by this HCl? Remember, this is a follow-up question from the previous question. So they are talking about this HCl of concentration of what? Of 0,0955 mole per decimeter cube. So they are saying this HCl reacts with sodium carbonate, and we are provided the formula of sodium carbonate as Na2CO3 according to the balance equation. So we are provided with the balance equation. What information do we get from our balance equation? We will always get the information on the mole ratio, on how many moles of HCl needs to react with how many moles of sodium carbonate, so that we can get the carbon dioxide, the sodium chloride, and water as our product. Therefore, if you look at the ratio of reacting, you can see that Na2CO3 is to HCl. The ratio is, for every 1 mole of sodium carbonate, I need 2. So already you know that whenever I know the number of moles of HCl, or whenever I know the number of moles of sodium carbonate, I will already know the number of moles that will react for each other, because I already know the mole ratio, and the mole ratio will always be provided to me by the reaction or the balance equation. Now the question says 50 cubic centimeter of HCl solution is added to 25 of 0,075 mole per decimeter cube of sodium carbonate. So what are we provided? You are provided with the concentration of sodium carbonate. You are also provided with the volume of sodium carbonate. Here you are provided with what? So let me just say the volume of a base, and this one is a volume of an acid that you are provided. And this is the concentration of our base, which is our sodium carbonate. So you can ask yourself, what type of a base is sodium carbonate? Is it a weak base? Is it a strong base? I indicated previously that all the carbonate bases are weak bases. So we already know that this is the reaction between a strong acid, which is HCl, and a weak base, which is sodium carbonate. Therefore, if maybe for some reasons the examiner asks you what type of an indicator are you going to use here, definitely will know that you are going to use methyl orange for this, because methyl orange is an acidic indicator, which is having the pH that is less than 7. Now, as we are provided this information again, you can also see that our bases are provided in our volumes are provided in cubic centimeters. Therefore, we already know that if you are provided the volume in cubic centimeters, we just need to divide by 1,000. We're going to say 50 divided by 1,000. And we're going to know that the volume of this acid is 0,05 cubic decimeter. And then here we are provided with 25. So it's the 25 divided by 1,000, which is going to be 0,025. So it is very important that you start by converting these volumes as you start with your question, because you don't want to forget and work with the incorrect units. The reason, remember, our concentration is given as mole per decimeter. Therefore, it means also the volume that you are working with must also be in decimeter cube, so that we use the correlating units. The question now says, calculate the concentration of excess hydrochloric acid in the new solution. That is very important. What do we mean now by the new solution? Remember, when you started with this reaction, you are having only 0.05 cubic decimeter of an acid, of a concentration which was given to you initially as 0.095. Remember, this is the acid that you started with as we are going to make it to react with the base. So that is your basic. You need to know what did you have initially. You had that 0.0955 mole per decimeter cube acid of 0.05 cubic decimeter as the volume. And you made it to react with 0.025 cubic decimeter of the, now we are having the concentration. And immediately we know that as we are provided with the concentration of a solution, we already know that we can refer this as our standard solution. What is the standard solution? A standard solution is the solution of a known concentration. So what the examiner did, the examiner gave us a standard solution of sodium carbonate, which is our beginning or as our initial point. And what else do we know from this question? So it means as we are going to take this acid and mix it with the base, we are going to find a new solution. The first thing that you need to ask yourself, what will be the volume of the new solution? Remember, the new solution will now be having the acid and the base together. So therefore, it means for a new solution that you are going to find after the acid has been added into the base or the base has been added into an acid, you need to know that now the volume will be added together because you are now dealing with two things in one container. So it means we need to combine the volume of a base and the volume of an acid together in our new solution. That is very key. So what is now another information that examiner is giving us? The examiner is telling us that now our acid is also in excess, meaning that if we know that our acid is an excess limit, an excess reactant, so it means our acid or HCl is our excess reactant. Therefore, our Na2CO3 is going to be our limiting reactant. What is the information that we are going to use for when we know the limiting reactant? It means the limiting reactant is the one that is going to be used up first and is the one that is going to determine our product. Therefore, when we use the mole ratio, we will always refer to our limiting reactant because that one we are definitely sure that nothing will remain inside the container without being reacting or unreacted. Therefore, it is very important that immediately when you know the number of moles of our limiting reactant, we are going to find the number of moles of our excess reactant so that we know how much of the excess reactant reacted. Therefore, as you see that we are having 8 marks, what I'm going to do, I will definitely ask you to just try and see whether you can attempt this question. I am not expecting you to get everything if you can't. But if you can, it's going to be very good for me. But what I want you to do, I want you to check whether you can move from things that you have, that you know, from things that you don't know. Meaning that you know what you have initially for an acid, you know what you have for a base, and then you can find what reacted between an acid and a base so that you can find what is in excess in that acid, and at the end you can calculate the concentration of an acid. So what I'm going to do, I'm going to give you just 4 minutes because it's 8 marks and there's too much that you have to do on this question. I'll give you 4 minutes just to try this question, and then when we come back after 4 minutes, we'll go and look at the possible answers. So our 4 minutes starts now, where we calculate the concentration of excess HCl in our new solution. Okay, grade 12, let's come back to our question. But before we come to our question, there is a WhatsApp that was sent by one of you. You never indicated the name of the school. I would like you, when you ask a question on WhatsApp, just indicate the name of the school or your name so that I know who am I talking to. I think the question was based on the previous calculations that we did. The learner is asking about where is the 98 coming from. Remember, the 98 that we are talking about is coming from the molar mass of sulfuric acid. Let's start and look at the molar mass of sulfuric acid. Sulfuric acid is, or hydrogen sulfate solution, H2SO4. So how do we calculate the molar mass? We are going to say the atomic mass of hydrogen is 1, but there are 2 hydrogens in this compound, plus sulfur. Sulfur is 32 from the periodic table, plus oxygen is 16, but there are 4 atoms of oxygen. Therefore, which means it's going to be 2 plus 32 plus 64. And when you add them together, you are going to get 98 grams per mole. I hope you've been answered in terms of how do you calculate the molar mass. But what you can also do as part of your practice, you can just look at different molecules and see whether you can be able to calculate the molar mass. Like maybe you can take magnesium hydroxide, so that you know that how do we deal with the issues of or atoms that are inside the bracket, meaning that when you look at these two, you know that this two is for the oxygen and the hydrogen. So it's the same as the magnesium plus 2 oxygen plus 2 hydrogen. So just try and check whether you can calculate the molar masses of different substances. I hope you've been answered in terms of where was the 98 coming from. You are more than welcome also, my learners, to ask as many questions as possible when coming to this topic, because this is one of the topics that carries a lot of marks in our examination. Therefore, it is very good that at the end of the day, you are able to definitely answer questions on this question. Now, let's look at our question. Let's go back to our question. Our question says we need to calculate the concentration of excess HCl. Now, let's go straight to our possible answers. I think we already know that the HCl that was having 0.0955 moles per decimeter cube. Therefore, the first thing that we can calculate the number of moles of an acid initially, and also calculate the number of moles of our limiting reactant. So what are we going to do? We can calculate the number of moles of our limiting reactant, which is sodium carbonate. This is the concentration of sodium carbonate. This is the volume of sodium carbonate, whereby we use the formula C is equal to N over V, or N is equal to C multiplied by V. Therefore, we are going to get the number of moles of sodium carbonate. And remember, sodium carbonate is our limiting reactant. Therefore, as sodium carbonate is our limiting reactant, it means now when we know the number of moles of sodium carbonate, we can use the mole ratio and know the number of moles of HCl that will react with sodium carbonate, because the mole ratio was provided to us by our balance equation. Then let's find the number of moles initially of hydrochloric acid. This is the volume, is the concentration of hydrochloric acid. Where did we get this volume of hydrochloric acid? This is the concentration that we got from the calculation of hydrochloric acid, where we were provided with the pH, because the examiner stated this hydrochloric acid or this HCl. So we knew that this HCl was the one that we calculated its concentration on our previous question. Therefore, we have the concentration initially of HCl, and we know that the volume is 0.05, which is the volume that we converted from 50 cubic centimeter to 50 cubic centimeter. Now we find the number of moles of the initial number of moles of HCl, which are the moles that we bring as we are going to make it to react with the sodium carbonate. Now, as we know that sodium carbonate react completely, now we want to see how many of hydrochloric acid will definitely react with this sodium carbonate, because we are told that hydrochloric acid is in excess. Therefore, by using the mole ratio, whereby we say the mole ratio between HCl and Na2CO3 is 2 for every 2 ACl, there is 1. Therefore, we are going to say X is going to be 0.001875 moles of sodium carbonate. And then by cross multiplying, that is why we're saying 2 multiplied by this number of moles of sodium carbonate. So it is very important that immediately when you know that the other substance is a limiting reactant, you already know that it's the one that we are going to use its moles in terms of the mole ratio to find the number of moles of the other substance that you don't know how many of it reacted. So that is the very vital information that you need to understand. Therefore, after that, we are going to find the number of moles of an acid that is being used or that reacted. So these are the number of hydrochloric acid that will definitely react with sodium carbonate from the mole ratio that we are provided. Now, we want to know now the number of moles that are in excess. As we know that not every ACl reacted, therefore it means we need to know how many moles of ACl didn't react. Then how are we going to get the number of moles of ACl that didn't react? It means we are going to take the initial number of moles of ACl and subtract the number of moles that reacted. And you can see that for this step, the examiner is providing you 2 marks because the number of moles that reacted didn't get any mark, but the mole ratio is the one that was awarded the mark because it's a skill that you use to find the number of moles that reacted. So the 2 marks now will qualify to say the initial number of moles that you had at the beginning, subtract the reacted or the used number of moles of hydrochloric acid so that you can get the number of moles that now are in excess. So 0,0095 moles are the number of moles of hydrochloric acid that are in excess. Now, as you know that the question required us to calculate the concentration of HCl in excess, let me just go back. So we know that we want to calculate the concentration of HCl that is in excess. Therefore, now we need to calculate the concentration. Already we know now the number of moles of HCl that are in excess. But what else do we know? The excess HCl, the concentration now, we are calculating it in the new volume. Therefore, what is the volume of the new solution? What is the volume of the new solution? So for us to find the volume of the new solution, which is very important, we are going to add the volume of HCl. We add it with the volume of sodium carbonate. And when you add 50 plus 25, it gives us 75 cubic centimeter. Then we know that we are dealing with cubic centimeters added hydrochloric acid and sodium carbonate. So as you look at this, you will see now that this is the number of moles of hydrochloric acid that are in excess. I think you need to indicate that. Divide by this one now is the volume, is the total volume, whereby now we are adding the volume of NOCO3 plus the volume of HCl. And when we add them together, they give us 0,075 cubic decimeter cube, which is the volume of our new solution. Then after getting this, when we divide the 0,0095 divide by 0,075, it gives us 0,013 mole per decimeter cube, which is the concentration of our hydrochloric acid, our excess hydrochloric acid in our new solution. So you can see that this is the combination, is a multi-step question whereby we have combined many information for us to get the new solution. But when you think about it, I think you can also draw a diagram for yourself to see what happens. You can start by saying, I'm having this container, which is having 50 cubic centimeter of HCl. Therefore, I'm making it to react with this container of 25 cubic centimeter of Na2CO3. Then when I'm making them to react, they will definitely go to a 75 cubic centimeter together. But what I know is that I also knew the concentration of this one, which was provided to me because this is my standard solution. which I can find the number of moles that will go into this beaker, and that is what we calculated initially, which are the number of moles of Na2CO3, and we find that the number of moles now in this beaker, they are 0.001875. Then you know now the number of moles of sodium carbonate that are inside the beaker. And you know also the number of moles of an acid that will come here, because we found it initial as 0.00475 moles. So it means initially we have poured the number, the 0.00475 of an acid, which is ACl, and 0.001875 of Na2CO3. That is what we did initially. Then you find that not everything of 0.0475 reacted inside this beaker. So you are going, but you know that everything here reacted. So that is why we have used the mole ratio to find what reacted inside this new solution. Therefore, after finding what reacted or what was used to react with sodium carbonate, that's when we found the number of moles that were in excess or that were unreacted. Therefore, after that, we find now the concentration of an acid in this container, which is 75 cubic centimeter, or you can say 0.075 cubic decimeter volume of sodium carbonate, which is added with a hydrochloric acid, and therefore you will find the concentration of an acid that you are looking for in the new solution. So just creating a diagram, sometimes we ask this to see exactly what you have initially, what reacted, and in which volume of a new solution are you dealing with, so that you can find your desired variable that the examiner will be asking you about. So the 8 marks is not just for one response. The 8 marks is all for the multiple steps that we have done in order to calculate the concentration of excess hydrochloric acid. Now let's look at this one. This one, it says the pH of carbonic acid is 3.4 at 25 degrees Celsius. Now the question says, calculate the hydroxide ions concentration in the solution. Now, as you know that carbonic acid is one of the weak acids, we know that we cannot calculate its pH, but the examiner can provide the pH and we can calculate the concentration of the ions. Now, the question looks for the concentration of the hydroxide ions. It is very important to distinguish between hydroxide ions and hydronium ions. We know that hydronium is H3O+, which is hydronium, and OH- is hydroxide. So they are looking for hydroxide, which is OH-. As I said when we began our topic, at the beginning of our topic, I said the information that we did previously in terms of calculating the pH is still going to be useful for now, because there will be instances where we are provided with the pH and we need to calculate the concentration, or we need the concentration of some of the acids and bases. Now let's look at this question. When you look at this question, you can see now that you are provided with the pH of this acid. Now, what are we going to do? Let me use this space here. We know that pH is equals to minus log the concentration of H3O+. You are provided the pH of 3.4 minus log the concentration of H3O+. I also said, if you are given something like this, you can also say concentration of H3O+ is equals to 10 to exponent minus pH. In this regard, it's going to be 10 to exponent minus 3.4. Therefore, when you go to our calculator, you can just write, do it straight as that one of 10 to exponent, which is going to be, okay, let me just do the pH. So we can say minus log, and then we have 3, 4, then we close the brackets, and then we find it as 0, 53. I think is the one. Let me just also use this one also to check, to verify my answer. And then to the exponent minus 3, 4. Oh, it's gonna be 3,98 times 10 to exponent minus 4. If I'm not mistaken, yes, moles per decimeter cubed. Therefore, we have calculated the pH, no, not the pH, the concentration of our hydronium ions, because those are that is the concentration that is provided by our formula. Now, the examiner doesn't look for the concentration of hydronium ion, but they are looking for the concentration of the hydroxide ions. Therefore, where are we going to find our concentration of hydroxide ions? We know that from the information where we looked at the ionization of water, or the constant ionization of water, we know that we provided Kw as concentration of H3O plus multiplied by the concentration of OH minus. Therefore, the value of Kw is provided as 1 times 10 to exponent 14. We already know the concentration of H2O plus, which is 3,98 times 10 to exponent minus 14. But we don't know the concentration of hydroxide ions. Therefore, how are we going to find the concentration of hydroxide ions? We divide both sides by 3,98 times 10 to exponent negative 14. Even this side, 3,98 times 10 to exponent, not minus 14, minus 4. I think I make a mistake here. It's minus 4, not minus 14, minus 4. Therefore, we are going to say, okay, 10 to exponent minus 14 divide by 3,98. Okay, let me just go straight to the answer before I divide. 10 to exponent minus 14, and then divide by 3,98 to exponent minus 4. And our answer is giving us the concentration of OH minus. If you can also check your answer and verify, 2,5 multiplied by 10 to exponent minus 12. Therefore, we know that we are looking for the concentration. Just make sure that you verify this answer using your calculator, and make sure that you use the correct operations for the exponential. You know where to press, and if the exponential is negative, you also know how to do it on your calculator. So always use the calculator that you are familiar with, so that you can get the desired answer. So now for the 4 marks or the 5 marks, let me just verify how many marks we required. Okay, it was 5 marks. So for the 5 marks, if we were just expected to calculate the concentration of H2O plus, which are the hydronium ions, I think the mark was going to be 3 marks. But now, because we are expected to calculate the hydroxide ions, we have moved further by using the constant ionization of water to find the hydroxide ions, or the concentration of hydroxide ions. Therefore, that is why the marks are going to be 5 marks for the formula of the constant ionization of water, and also for manipulating to find the concentration of hydroxide ions. The second question says, X is our monoprotic acid. What is important here is the information that you are provided as monoprotic acid. Now, the first thing you need to ask yourself, what do we mean by monoprotic acid? We know that monoprotic acid is an acid that will do what? That will donate one proton. So already we know that this is an acid that will donate 1 proton. And this acid, the first question you are definitely asked, what do we mean by monoprotic? And we've already answered that. So you can see that in some of the information that the examiner will give you, you need to firstly scrutinize the statement that you are provided before you can even go to the questions itself. So already when they say acid X is monoprotic, you need to ask yourself, by the way, what do we mean by monoprotic acid? Now, a sample of acid X, which is our monoprotic acid that we are provided above, is titrated with a standard sodium hydroxide solution using a suitable indicator. We cannot say what will be our suitable indicator because we cannot identify acid X at this point in time. But the only information that we know is that our acid X is monoprotic, meaning that it can give us only one proton, or it can donate one proton. Now, you are also told that this sodium hydroxide solution is a standard solution, meaning that we need to know the concentration of that sodium hydroxide solution, because if we are referring to a solution as a standard solution, it means it's a solution of a known concentration. Therefore, at the end, it is found that 25 cubic centimeter of acid X is neutralized by 27.5 cubic centimeter of sodium hydroxide of concentration 0.1. As I indicated, that definitely we need to know the concentration of sodium hydroxide because we are told that it's a standard solution. Now the question says calculate the concentration of acid X. This is a neutralization reaction. So during neutralization reaction, we know that a certain acid of number of moles will react with a certain base of certain number of moles, whereby we normally use the formula that says CAVA over CBVB, which is the formula that we used previously when we were calculating the concentration, is equal to the number of moles of an acid over the number of moles of a base. So this is the formula that we normally use when we are looking at the neutralization reaction, because an acid is reacting with a base, an acid of certain number of moles reacting with a certain base of a certain number of moles. Our examiner looks for X. Now, our catching part is the number of moles. To say now, how many moles of an acid will react with how many moles of a base for us to write the Na and the Nb in terms of a certain ratio. Immediately when we are told that our acid is a diprotic acid, then we need to assume, or we need to create a scenario whereby we know how the acid and this sodium hydroxide will react. Let's say, let's find the number of moles of an acid that will react with the number of moles of a base. Let's say we have acid HX, because we know that it's a monoprotic acid. React with sodium hydroxide to give us what? We know that we're going to have sodium X, I don't know whether it's chloride or whatever, it depends on what X is, plus water. Now, when you look at this reaction, let's see whether our reaction is balanced. We can see that this side we have 2 hydrogens, and also this side we have 2 hydrogens. We have 1 X, we have 1 X. We have 1 sodium, we have 1 sodium. We have 1 oxygen, so our equation is balanced. So it means the ratio in which the acid X will react with sodium hydroxide, they will react in the ratio of 1:1. Therefore, we already know what is Na and what is Nb. Na is 1, Nb is 1. How did we know that? We knew that by balancing the reaction between acid HX and sodium hydroxide. What about if the examiner said X is a diprotic acid? Will sodium hydroxide and acid X react in the same ratio? Let's check. We know that a diprotic acid is an acid that produces or that can donate 2 protons. Therefore, it means instead of HX, we're going to have H2X, which will react with NaOH. We are creating a scenario. Now, it means remember the 2, it means it's going to be H plus X2 minus. Therefore, the 2 now is for the S, so it means we're going to have Na2X plus H2O. Then if you look at our reaction, whether it's balanced, 2 hydrogens, the hydrogens are balanced. 1X, the X's are balanced. But when you look at sodium, this side we have 2, this side, so it means we have 2, we need 2 here. And immediately when you need 2 here, it means we'll also need 2 here, because we'll have 2 plus 2, which is going to be 4, and 2 times 2, which is going to be 2. So our equation is balanced. So you can see that now, when this acid is now a diprotic acid, it's not going to react in the ratio of 1:1, but it's going to react in the ratio of 1:2. So the information that we provided at the top to say this acid is a monoprotic acid is very important for us to know the ratio at which this acid will react with the base. Therefore, we already know now that the acid and the base will react in that ratio. Therefore, let's look at how are they going to react. It means we're going to have CAVA over CB VB, which is equal to NA over NB. Therefore, our acid, we don't know the concentration of an acid, but we know the volume of an acid. We are provided the volume of an acid was 25 cubic centimeter, which we know that if we divide it by 1,000, let's always verify, divide by 1,000, which is going to give us 0,025. Divide by, the base was 27,5, which we're going to divide it by 1,000 also, which is going to give us 0, okay, let me just start with the concentration. The concentration was provided as 0,1 multiplied by 0,0275, which is equal to 1/1. So when you cross multiply, it's the same as CAVA is equal to CBVB, because of that reason that the ratio is 1:1. Therefore, for us to calculate the concentration of an acid is going to be multiplied by 0,025, which is equal to 0,1 multiplied by 0,0275. So this multiplied by 0,1, it gives us CA is equals to, no, multiplied by, okay, I can just say equals to 2,75 in an exponential form. Even if it's not in exponential form, it's okay. It's still correct. Divide by 0,025, which is the volume of an acid. Then what is the concentration? Divide by 0,025, which is the concentration of an acid. And our answer is 0,11 mole per decimeter cube. So this is the concentration of acid X. After realizing that acid X and our base, which is our sodium hydroxide, reacted in the ratio of 1:1. So the concentration of acid X is 0,11 mole per decimeter cube. Remember, we are calculating the concentration, so we definitely need to write the units. Now, they say in the next question, the concentration of hydronium ions in the sample of acid X is 2,4 times 10. So they are telling us that when X ionizes, remember we have HX, acid ionizes to form H plus X minus. We know that the concentration of acid X was 0,11 mole per decimeter cube, but we are told that the acid ionizes, it produces, and when they look at the sample of the ions that acid produces, it is 2,4 times 10 to the exponent -4, which is the same as this one because they react in the ratio of 1:1. Now, what does this information say to us? Did acid HX ionize completely? Let's look at the concentration of the ions. Is the concentration of the ions the same as the concentration of the acid X? Is it more than or less than the concentration of acid X? We know that if you are having the concentration after ionization of the ions, you will always compare it, whether to see that acid ionized completely or what. Then by looking at when you compare 0,11, as you compare it with what? With 2,4 times 10 to the exponent -4. You can see that the concentration of the ions that are going to be produced will be less than that one of an acid. Why? How do we define a strong acid? We say a strong acid is an acid that ionizes completely. And we also say that as the strong acid ionizes completely, the ions that are going to be produced, they will produce a high concentration of the hydronium ions. Whereas the weak acid ionizes incompletely and it produces a low concentration of hydronium ions. And when you look at the ions that are being produced in terms of the concentration of this acid X, you can see that the concentration of the ions that are produced by acid X is lower than that one of X. Therefore, is acid X a weak or a strong acid? Explain your answer by referring to the question above, or the question above, which is this one, where we're calculating the concentration of acid. Definitely, acid X is a weak acid, meaning that the concentration of the hydronium ions are lower or are less than that of X, because they are -4, 2,4 minus 4, which is 0, we can say 0,00024 mole per decimeter cube, which is less than 0,11. Therefore, this is an indication to say acid X is a weak acid. It ionizes incompletely because the concentration that it will produce will be of low concentration. So you can provide to say it's a weak acid for 1 mark, and then you can say the concentration of acid X is greater than that one of hydronium ions. And the other reason is because acid X is a weak acid and it ionizes incompletely. So that will definitely qualify you to get the 3 marks for that question, because we have explained into 2 facts in terms of the concentration of the ions, and also to say why do you know that the concentration of the ions will affect acid X as being a weak acid, understanding that weak acid ionizes incompletely and they will produce a low concentration of hydrogen ion. Let's look at this other question. Now here you are provided with 2 acids, acid HX and acid HY, which are equal, I think the Q is missing here, of equal concentration are compared. Now you are provided with the pH of acid X and the pH of acid Y. The acid X pH or HX is 2,7 and the pH of acid HY is 0,7. Now we know that one of the requirements that we need to have, we are required to compare the strength of the strong acids and the weak acids in terms of their pH. So as we are provided the pH of acid HX and acid HY, you can see now the first thing that will come to mind is acid HX or acid XY, which one is stronger as compared to the other. So the value of the pH will tell you that already you know that acid HY will be stronger than acid HX. What is the reason? The pH of acid HY is less than that one of acid HX. That's the information that the examiner is giving you. Then the next thing, they said define an acid according to Arrhenius. I think we can all do that because we know what are the definitions according to Arrhenius. The next question definitely will ask, which acid HX or HY is stronger? Give a reason for your answer. So already we have identified our HY as our stronger acid. The reason is because it is having the lower pH than HX. Therefore, I think that will definitely qualify you to. You cannot talk about Ka value here because the examiner didn't give you the Ka value. The only information that you are given is the pH. Then acid HX ionizes in water according to the following equation. So you can see HS plus water give you hydronium ions and X minus ions. Now you are now given the Ka value, and when you look at the Ka value, the first thing that you ask yourself is the Ka value greater than 1 or less than 1? And if you can see that it's -5, it means this Ka value is what? Is less than 1. And if the Ka value is less than 1, already you know that you are having a weak acid. And what is a weak acid? An acid that ionizes incompletely to give you a low concentration of hydronium ions. Therefore, the question says, is the concentration of hydronium ion higher than lower than or equal to that one of the concentration of HX and give the reason. Already you have answered your question to say this one is a weak acid, therefore the Ka value is less than 1, meaning that the concentration of this acid will be lower than that one of an acid, just like the previous question that we did. Now, how do you answer the other mark? You can say Ka value is less than 1, or you can say it ionizes incompletely to form low concentration of what? Of hydronium H3O plus ions. So this is the two ways that you can explain why I'm referring to this acid as a weak acid. Sulfuric acid ionizes into 2 steps like this. The first question is said, define acid according to Lorentz-Bronsted, which we can do that, I think. Write down the formula of 2 bases in the reaction. As you can see, this is an acid, obviously, which is a strong acid, and this one will act as a base. And this one, definitely, these are the ions that are formed by an acid, and this one are the ions that will be formed by this sulfuric acid. Acid becomes, or acid donates a proton. So our bases here will be our H2O and our HSO4 minus. Identify a substance that can act as an ampholyte in this reaction. We know that water can act as an ampholyte, and also we can also have what? HSO4 minus acting as an ampholyte. As long as there's a hydrogen and a minus in that substance, it can donate, it can also accept a proton. Now, the table below gives you an information about solution of 2 acids and salts. When you look at the first one, you can see that you are given ethanoic acid and you are given its Ka value. Sulfuric acid, the pH, sodium carbonate, and the pH. So for the method that you are given this Ka value, you already know that this is our weak acid. And we know that sulfuric acid, looking at this pH, is our strong acid. And this one, because the pH is just closer to 7, it means it's our weak base, because that's how we identify our pH. So already the information that you are given or you are provided on the table, you can analyze it and interpret it with whatever information that you got in our previous lessons. Now, is ethanoic acid a strong or a weak acid? Give a reason for your answer. We have identified it as a weak acid. And the only thing that is telling us that is the weak acid here is because the Ka value is less than, or Ka value is less than 1. Which indicates that this is a weak acid. It will ionize incompletely. So already you cannot give the definition of a weak acid, but you can make reference of the Ka value that you are provided by the examiner to explain why we are saying this is a weak acid. Which acid, ethanoic acid or sulfuric acid, will react faster with sodium carbonate? What did we say about the reaction rate of acids which are weak and acids which are strong? We said the weak acid will react slower as compared to the strong acids. Therefore, meaning that the weak acid will have a low reaction rate as compared. Therefore, after identifying that this is our strong acid and this is our weak acid, it means now which one will react faster. We know that H2SO4 will react faster because it's a strong acid, and strong acid ionizes completely. So that is why it reacts faster, because it will ionize completely as compared to ethanoic acid. Then the question says, calculate the concentration of sulfuric acid. Now, how do we calculate the concentration of sulfuric acid? We are definitely going to use the formula pH is equal to minus log the concentration of H3O plus to get, but what is it that is entailed in the sulfuric acid? We know that sulfuric acid, as it's going to ionize, is going to give us 2H3O plus SO4 2 minus. Therefore, when we calculate the concentration, after getting the concentration here, we are going to multiply it by 2 for us to get the concentration of sulfuric acid. Explain by using the relevant equation why Na2 is greater than 7. This is through hydrolysis, where you are going to make Na2CO3 react with water. And when the OH minus ion are formed, because we are going to get what? OH minus plus H2CO3, I think as one of the products, because this is going to be the weak acid that is going to be formed. So as the OH minus are going to be formed, or we know that this is going to be our weak base. So you're going to just complete this by looking at making this sodium carbonate to react with water to see that hydroxide ions are formed, and you'll know that definitely is a base. Okay, learners, we have come to the end of our lesson. I hope by the 2 calculations that we have done today, you can be able to interact with other calculations and see whether you can be able to gather the information that you have to calculate the unknown concentration or the unknown mass or the unknown volume of an acid and a base. We have come to the end of our lesson. Make sure that you keep on studying. We are about to write our prelim exam. Make sure that you have 2 subjects that you study every day, and you have your study timetable that you are using daily, so that by the end of the year, you can yield good results. From my side, from Saibono Discovery Center and Gauteng Department of Education, until next time, goodbye.